I was going to ask Andrew, was LocationTech one of the first working groups?
There's some interesting history that I talked about. It was one of the early ones.
Okay. Working on it. Pardon?
If you don't want to wait anymore, you can start.
Okay, is it time to start?
Yes.
Okay. So, good day. My name's Jody Garnett. I'm from a company called Boundless, and I'm here today to talk about one of the industry working groups, LocationTech. Nominally, I was going to talk through some of the LocationTech projects and what kind of information they're working with and what they're useful for. I guess the other thing that I need to do is introduce LocationTech to everyone in the room. And just would like to introduce Andrea here.
So, hi everybody, I'm Andrea Ross. I work for the Eclipse Foundation. My job is kind of interesting actually. I run around and help folks like you get involved in some really cool technology projects. I also help a lot of member organizations who are using the technology to build products and services or solve problems. I help them to do that as well. So I'm responsible for the LocationTech working group, and if you've heard of the science working group, I'm also responsible for that. And pretty much anything to do with the Eclipse Foundation. If you're interested in chatting with me, I can help you and connect you to the right people and members and projects and whatnot. So I guess we'll keep going. I'll stand close to Jody so the recording can hear me a little better. So many of you, just before we got started, didn't seem familiar with spatial data, so I'll give you a bit of a 30-second primer. So you guys are familiar with Cartesian coordinates, X and Y or X, Y, Z. So spatial data is basically taking that Cartesian coordinate system and applying it to different spaces. So sometimes the surface of the Earth, could be Mars, the Moon, whatever. Could be an area in a factory. So mathematically, we're representing a series of coordinates or points. So if you have an X coordinate, Y coordinate, Z coordinate, sometimes in M, like you want to represent cost or time or something like that, it allows you to identify a point in space and time. If you take multiple points, say a start point and a stop point, you've got a line string, so you can represent a path between two points. Or you can even take multiple points along the way, and so you have a start point and an end point and any number of points in between. So these basic constructs we actually use to build up a series of shapes or features to represent mathematical data. Now that's what we call vector data. The other side of it is taking pictures. So you guys have all seen satellite images, I'm sure, like weather images or these kind of things. So that's basically raster data. So some of the projects we're talking about work with vector data. They also work with raster data. And they also do some other really cool things. So that's what LocationTech is all about. Now we're basically making technologies so you can use these basic building blocks to build complex systems that are spatially aware. So LocationTech is a working group. Just a quick show of hands. How many people aren't familiar with what a working group is at Eclipse? Because I might talk about it for 30 seconds. Okay, yeah, good. There's enough people from yourself. So Eclipse is really big. 270 plus projects. You probably heard Mike say in the keynote. Almost a similar number of member companies. We're about 240 member companies. And so such a large community means that it's very easy to get lost, right? In that if we're focusing on spatial technologies like LocationTech is, and there's a lot of other projects that are focusing on development tools or Internet of Things. One huge community without any sort of abstractions or sort of groupings would be really hard. So what we've done is created this working group concept to bring special focus for people who are all doing development and solutions in a certain particular domain. So LocationTech is obviously the geospatial working group. Science is focusing on scientific software like data analysis, visualization, simulation. We've got an automotive working group, and there's a whole bunch of other ones as well too. So these members, in fact many of them are represented here today, are basically organizations who care about systems that process spatial data and have spatial awareness. What's particularly cool is some of the big names you obviously recognize. there's a nice balance. So Boundless, do you know how big Boundless is these days?
I haven't really been paying attention, sorry.
So last time I think it was sort of 60-ish kind of thing.
Okay.
So it's a good size, sort of small, medium-sized company. But they're on the LocationTech board along with massive companies. So one of the cool things about the working group is it allows bringing innovative companies who are doing really useful work and cutting-edge development alongside companies who are sort of building the systems that are widely deployed, but maybe not necessarily as cutting-edge. And so many of the organizations here, just a few to call out. So Chris is in the back from Planet Labs. If you get a chance on Thursday, so Thursday just after the keynote, I highly recommend you catch Chris's talk about Planet Labs and what they're doing. It's basically microsatellites that image the Earth every day. We've also got interesting organizations. So Joe is here from Ordnance Survey, which is the UK's national mapping agency. So you have tech companies who are building solutions. You have tech companies who are building components that are used for solutions. Government agencies. We have some universities. So it's a really interesting mix of people and organizations. We are just in the middle of what we call the LocationTech tour. So how many of you been to a Eclipse demo camp before? Some, okay, but not all. So the tour, LocationTech tour is similar to the Eclipse demo camps. It's basically a series of regional events where we do sort of a mini conference like this. So people can hear about the technologies, meet the developers, meet people who are using the technologies, and get to participate in the community. So we actually bring them to cities all around the world. This is the third year we've done it, and it continues to grow, which is really cool. Some of them, like New York City, I think we sold out at about 200. The events Jody did in Victoria actually were outstanding, and you also filled the space. It was a slightly smaller space, but a good event there. So this is sort of a small toe dip of LocationTech at EclipseCon Europe. We did a much bigger thing in California, so I don't recognize many faces from the California conference. So what we did is hosted EclipseCon North America and FOSS4G North America together, and the amount of content we had meant that we drew about 430 people who are doing work in this area of geospatial technologies. So it was a lot of fun and a really cool event. It was about the same size as the EclipseCon conference, so it was a really nice culture shock for both parties. So I think that's it for my content. So I'm going to sit down. If anybody's interested, I'm going to hang around after and be glad to talk with you. Okay. And we do have a LocationTech day here on Thursday. We divide LocationTech up into a number of different streams. The first stream I'd like to talk about is the libraries. So these are probably the first projects you'll pick up and use in Eclipse RCP. And these are really the fundamental building blocks of our industry. And I'm really glad to see LocationTech providing these libraries a home. Yeah, a lot of the other software foundations that work in this area tend to focus more on end user applications. And so this is a really strong role that LocationTech is playing. The first one I'd like to talk about is called JTS Topology Suite. So JTS Topology Suite is originally developed in Victoria, which is where I'm from, by this fellow called Martin Davis. And it's really the rocket science of our industry. And by rocket science, I mean something called point set theory. So this is the mathematical abstraction about some of what Andrea was talking about with points and lines and polygons. And it takes a great deal of effort because it's not only making the data structure, which you can kind of do in a couple of days, but actually doing all the hard math. In particular, these data structures work at the limits of floating point and double precision, and it can be the work of years to make sure that all the algorithms are computationally stable. So JTS is built around a data model provided by the Open Geospatial Consortium, the OGC, and you can see they're representing points and lines, and linear rings is a line that closes in on itself, and you can use several linear rings to form a polygon, such as the city limits or something like that. And JTS, in addition to the data structures, has a whole wealth of spatial predicates, so you can compare geometries with each other, see what's contained within another
geometry. Can do all kinds of producing geometries, producing a buffer around a geometry. So this here is the fundamental building block of our industry. JTS includes, as a library, it's a little bit difficult to visualize. It includes a test builder, which is a good way to try out the operations. The other thing that's interesting here is JTS has been ported to many different languages. So JTS itself is written in Java, and it's used from Scala projects and Python and whatever else. It's also been ported to JavaScript as the JSTS project. It's been ported to .NET, and it's also been ported to C++ as the GeoScipt project. And so this one Java library is responsible for our entire industry. The next project I'd like to talk about is called Spatial for J. So JTS was really focused on representing these data structures on a flat plane. Spatial for J starts to represent these data structures, but on a spherical world. So rather than having a triangle made up of lines, you'll have a triangle made up of great circles. Trying to think what else here. So Spatial for J is used to calculate distances on the world. So it's very useful, rather than JTS, which is used to calculate distances more at like the city level. So this is kind of described as a romance in many dimensions. You can see JTS was focused more on the Cartesian plane. Spatial for J is looking at other projections such as spherical or Euclidean. Spatial for J is just made a release this last September, and it's coming very close to finishing its LocationTech incubation process. So this is likely to be the first project to graduate from LocationTech. The next project I'd like to talk about is Mobile Map Tools. So Mobile Map Tools is a project focused on cell phones, iOS and Android, and you can set up your application with Mobile Map Tools and cross-compile for the different platforms. So it takes the form of an SDK, and it makes use of the appropriate visualization framework on the mobile device. And you can see a few of its capabilities here: 3D buildings, working with raster data, working with elevation data, and also working with vector tiles. Another interesting data structure we haven't talked about is point clouds. Has anyone heard of laser radar, maybe in use with car navigation or drones? They produce massive data sets, which can be good fun to visualize. Another key aspect of LocationTech is working on processing spatial information. And this is another area where LocationTech is pulling players out of the industry, which we have not necessarily seen before. So in this case, we're starting to pull together various groups that have been working with cloud processing. So the first one here is the GeoMesa project, put together by CCRI. Anthony Fox is the project lead. And it's a spatial processing project built on Hadoop and Accumulo, and it scales out to billions of features. It's written in Scala. How many people work with Scala? A few people? It's very popular in the cloud computing space. We're seeing a lot of use there. So it's built on the Hadoop file system and Accumulo. Here's just an example use. You can see that they're able to put together a query and query out to GeoMesa across a range of data sources. We can see something called a predictive threat surface. And I think I have a short video here. There we go. So here's a little bit of what GeoMesa would look like in action. I think I'm probably going to skip over this. So I will post this one online. Next project I'd like to talk about is called GeoTrellis. And GeoTrellis is a project I'm very fond of. It really focuses on fast raster processing. Once again, it's another Scala project. And it tends to be built on a different stack. So it's built on Spark, I think, is the main focus. And it's an Apache 2 license. So here's an example of kind of what working with GeoTrellis looks like. And we've got a range of demos here. So this is kind of fun. For the amount of data that's being processed here, these applications are considered extremely responsive. So if you have any questions about GeoTrellis, we've got Rob here in the room. Be happy to talk to you. And here's a little bit of what GeoTrellis is about. Here's a comparison of a solution built with Hadoop with a solution built on Spark. And you can kind of see why GeoTrellis is making the technology choices they have. Another project I'd like to talk about is an example of LocationTech working with academia. So the GeoJinni project, it used to be called Spatial Hadoop, but when they joined LocationTech and did their trademark check, they got to rename themselves to GeoJinni. They're obviously built on a Hadoop backend. And they tend to focus a lot on batch processing. And once again, they're highly scalable. You can see they're working with a fair amount of index data. The final aspect I'd like to talk about for LocationTech is applications. And not to worry, a few of these applications will be Eclipse RCP based. The first one here is called GeoFastForward. This project is really interesting that it is Eclipse RCP based. But what they've done is they've used an embedded browser to leverage one of the leading JavaScript frameworks called OpenLayers. So it allows them to embed a simple but very powerful mapping visualization in your Eclipse RCP app. And it provides a data structure of a map consisting of layers, and it's able to turn this into a visualization for you. So here's a little bit of what that looks like in Eclipse 4. So I do recommend you start with this project if you're wanting to get a quick start of mapping in Eclipse. Another interesting project here is called GeoGig. I assume everyone here is familiar with Git. Git has a little bit of a trouble working with spatial data. So we've started this project here at Boundless called GeoGig, and rather than work with lines of text, we're working with individual features, the individual shapes, but we follow the same workflow as Git. So I do need to say that GeoGig isn't Git. And we offer a really friendly user interface in the form of a command line. It is also available as a library to use in your own application. And it offers all the same kind of power as Git in terms of branching and tagging and so forth. The production of data sets is a challenge for the spatial industry. And so this project is really of great interest to a lot of people. And we've started embedding, sorry?
What does a conflict look like there?
I think I've got a picture of that later. So we started embedding GeoGig in one of the leading open source desktop applications called QGIS. And you can see that we've got diffs, and if you did have a spatial conflict, you get a visual like this, and you get to resolve it. But a very good question. We do have a beta available for download. We are gradually completing our LocationTech incubation requirements. Unfortunately for us, we've got our first round of IP rejections, one of which was we were using the Berkeley DB for our default local storage, and we're having to replace that, I believe, with SQLite. Another project that we've got is called GeoScript. So GeoScript represents adapting one of the geospatial libraries called GeoTools to a range of dynamic scripting languages: Groovy, Python, JavaScript, Scala. And so we can have kind of the same code example in a number of different languages. And this project has not really started its incubation process, just because LocationTech has been a little bit stuck with just the sheer amount of new IP that's coming through the system. So GeoScript's turn hasn't come up yet. The last project I'd like to talk about here is called uDig. So this is a project that I work on. And this is a desktop GIS application built around Eclipse RCP technology. And it's kind of done in two forms, one of which is a desktop application that end users download, and the second one is an SDK that you can use in order to add this functionality to your own application. So here's a few of the services that the SDK provides. And here's the default application that people can download and try things out. And this is used in other applications. Here's one for hydrological modeling. Here's another one for early earthquake warning system. So you can see that the same SDK components are being used in a range of software systems. Here's one, I believe, used in forestry for asset management. Andrea, I was going to turn over the what's next for LocationTech to you. How are we doing for time? I'm probably going ahead of schedule here.
It's okay. We both talk really fast, so we got us. So, as you see, we have a fairly good number of projects. They've been working for a little while, a couple of years, and what we're looking to do is get them to graduate. So actually do a formal release. We can put on the download site. Projects like Spatial for J and GeoMesa are pretty darn close. So one of the things we're going to do is basically do a code sprint to help basically get these projects to do some releases. It may turn into eventually what becomes a simultaneous release for LocationTech, just like the simultaneous release for the Eclipse Foundation, which sort of helps us market all of the projects together, get people to test them, working with each other, and those kinds of things. So. You saw we had a number of members. What's interesting is actually been working for a while with an organization called the National Geospatial Intelligence Agency in the US. So I know we're in a European audience, and when I talk about three-letter agencies in the US, people kind of go, this is, well, actually they do have some security and intelligence stuff that they do, so that's truly fair. But they're not actually the NSA or those guys, although they do work with them. So, but it's actually quite cool to have such a large government agency interested in the group, interested in collaborating in the open and working with the open source technologies that we're nurturing. So,
I know Ordnance Survey is ahead of the curve there, but
yeah. So we have a lot of big data projects at LocationTech. It's neat to see some visualization technologies come in, so like the Torque JavaScript library. So if you wanted to basically do a visualization to show people tweeting about a particular topic, like say a hurricane or an earthquake, this is the kind of library that you could basically hook up to your data source and do that. The GeoMesa project that Jody mentioned, we have another one very, very similar to it. So NGA and others, Radiant Blue and a few other organizations worked on something that effectively, tried to solve the right problem. They're essentially building something that looks and smells an awful lot like GeoMesa, only because they didn't know GeoMesa existed. And so by bringing the GeoWave project in, we're actually getting some reuse of components between them. And who knows, potentially in the future the projects might merge together, but at the least they're both coming into LocationTech, which is further strengthening LocationTech's position as sort of the big geodata community for these technologies. We have some other interesting ones, so I can't tell you about the names just yet, but there's two really cool actually IoT projects. So they're basically doing Internet of Things, but they also have a very strong spatial component. There's also a visualization project that's come into the science working group that's basically got some cross-pollination and idea sharing and probably some reuse across the two working groups. So it's pretty cool to see that. There's more beyond that. I'll just mention casually that we have some indoor navigation projects that are coming in. And so if you're interested in that kind of stuff, talk to me after. I can give you a bit of a brief of what's going on. And do you want to talk about the step?
Sure. One of the things we're doing here at LocationTech is we're assembling a software stack so that the Eclipse community can start to be a little bit self-serving in terms of their geospatial needs. We actually have a few gaps in our technology stack. One gap we have in the Java world is a lot of these projects depend on a library called Java Advanced Imaging from the days of Sun. And this library sadly is not open source. So we are looking at possibly collaborating with the science working group on producing a replacement. Another gap that Andrea just mentioned is indoor mapping is a very hot topic worldwide, and there's lots of open source projects springing up, and we would like to be involved in that. Another interesting gap that's going to be difficult to fill is the concept of a geocoder. So right now, if you go online, you can type in an address, and geolocation is the process of finding the correct location for that address. These projects are technically very difficult to write, and one of the major difficulty is that the projects depend on having a constant and accurate stream of data to work against. Which brings us to the kind of last gap we've got in our stack, which is the geospatial industry gets partly on technology and partly on data. There's a number of open data initiatives going on worldwide, and we'll be looking at how we can best engage and participate. Another couple things, you saw the little picture of Phosphor-G NA last year that was co-hosted with EclipseCon. We've got a lot of the same crew putting together this year's event, and the call for papers for that opened up, I believe, just last week. So any questions about that? I think I'm way ahead of schedule. Certainly.
So if you're talking about a large volume of data,
Yeah.
which especially you used many times, I think, in your talk,
Right.
what's the order of magnitude that we are talking about?
It's hard for me to know where to start. So one thing that's happened almost since the 70s is the GIS industry has been